Hi there, so this is lesson 14.2, Growth and Decay part 1. I've split Growth and Decay up into 3 parts just to make it a little bit easier for you to follow. So today then we're going to have a look at the objective to be able to calculate compound interest. Again then, just to make sure we've got our prior knowledge before we start, so being able to find percentages of amounts, changing between percentages and decimals by dividing either in your head or on your calculator, and most importantly being able to calculate percentage increase and decrease. Again, if you've forgotten any of those things, you need to go back and refresh them, then please stop this video, go back and have a look at those first. Alright then, so compound interest. So we will talk about compound interest a lot when we're looking at savings accounts. So that's usually the questions that you'll get. Most of the time it's about some sort of savings account. So compound interest is where we're gaining money. So it's an increase in our money. So Jack puts £500 into a savings account with an annual compound interest rate of 5%. Now just to make it clear as well, the word annual means yearly. Okay, so if we see the word annual anywhere, then we're talking about a year. How much will he have in the account at the end of 4 years if he doesn't add or withdraw any money? Okay, so at the end of each year then the interest gets added on to the total that's in the account. So 5% of whatever money is in there at the end of that year, and then the next year he'll get 5% of however much is in there then, so there should be even more money in there. So it's 5% of a bigger amount. So to increase by 5%, we need to know our decimal multiplier. Again, because we're increasing, we already have 100%, so we're adding on the 5% to 105%. To turn that into a decimal multiplier, to change from percentage to decimal, we divide it by 100, so we get 1.05. So we can do that for each year that we keep the money in the account. So the first year then, he's got £500 he's put in. We're multiplying by our decimal multiplier of 1.05. So at the end of that year, he would have £525. Now at the beginning of the next year, he's already got that £525 in the account. So that's the new value that we're going to increase by our 5%. So again, the same decimal multiplier times in by 1.05. At the end of the second year, he has £551.25, rounded to the nearest penny. We do the same for the third year. So the third year, again, we've started with our new amount. We've ended with £578.81. The fourth year, starting with our new amount, we end up with £607.75. to the nearest penny. So after 4 years, he's got £607.75. Now that method's great if we only need to do that for a small amount of time. If we needed to do that for a longer period of time, let's say we want to do that for 20, 30 years, that would take us quite a long time. But if we look at those calculations, hopefully we can see that every time we're multiplying by 1.05. So all we're really doing is putting in the 500 times 1.05, pressing equals, and then multiplying that new number. So instead of pressing equals in between to get all the totals in between, we could just type in 500 times 1.05 times 1.05 again and again and again for the 4 times that we want it, and get the same total straight away. So all we're doing is skipping, pressing equals in between each of these calculations, and that's made it a lot shorter. But again, we might be able to shorten it further if we remind ourselves that when we multiply something by itself, we can use our indices or our powers to represent that. So a number multiplied by itself would be to the power of 2, multiplied by itself again to the power of 3, multiplied by itself again would be to the power of 4. So using our index notation, we can say we have 500 times 1.05 to the power of 4. The 1.05 has been multiplied by itself 4 times. So a much quicker way of getting to the same answer. Okay, so now we've got a shortcut to get there. We can see how much he would have after 10 years. So if we use that same idea, we've got the £500 we started with times our 1.05, our decimal multiplier for our 5% increase, and all we've changed here then is our power to 10 to represent that we want to do the 1.05 10 times. So 1.05 times itself 10 times, just to be really clear. That gives us £814.45. And we can now do that for any amount of years. So all we're doing is changing the power to change the number of years we want to calculate. So for 15 years, we would end up with £1,039.46. So the way it works then is that we start with our initial amount. We then multiply by our increased decimal multiplier. So remember, compound interest is an increase, so 100 plus our percentage, then dividing by 100% into a decimal. And the power is simply the term. Now for this one, we used a term in years. We could also have the term though in quarters, so quarters being a quarter of a year, so there are 4 quarters in a year. Or we could have it in months, and again we should know there are 12 months to a year. So we need to be careful about what we're being asked. So if we're given the interest rate annually, then we can work that in years, but we could be given the interest rate as quarters or monthly as well. So let's have a look at some more examples. So we've been given £1,000, we're going to put it in the bank and want to leave it there for 3 years. An interest rate of 1.2% per quarter. How much will we have at the end of 3 years? So we start with our initial value. Our initial value is the amount we want to put into the account. So we've got £1,000. We then multiply that by our decimal multiplier. So an increase, remember we have 100%. We want to add on 1.2, so that's 101.2%. Change that to a decimal multiplier by dividing by 100, and we have 1.012. Now our power, remember, is the term. Now we've been asked for 3 years, but we're getting our interest every quarter. So there are 4 quarters in 1 year. We want 3 years. 3 times 4 means we're going to gain interest 12 times during that 3 years. So that's really important that we check how long this term is. How many lots of interest are we going to get throughout our savings? Put that into our calculator. We get £1,153.89 at the end of our 3 years. If we want to work that out over 5 years, we're going to do exactly the same, but we need to change our power again. So 5 years. In 5 years, 4 quarters per year. 5 times 4 means we're going to gain our interest 20 times throughout that period. So the only change we need to make is to this index. This power now becomes 20, the amount of times we're going to get interest given to us. And if we do that, we get £1,269.43 to the nearest penny. For 10 years, the same idea then. So we still start with £1,000. Our interest rate is still the same. So in 10 years, 4 quarters per year, so 4 times 10, our power is going to be 40. So after 10 years, we've got £1,611.46. If you need to, make sure you pause the video now, work through the example yourself, check that you are happy with those calculations and that this time we've used quarters instead of years. Okay, so let's have a look then at where we might want to use this in real life. So we've been given £1,000 and we've got to decide which of these bank accounts is the best one to put our money in for the 3 years. We've made a note here, look, to check the period the interest is paid. So this is something that hopefully you will do at some point before you finish school, is to open a bank account and to decide which is the best one for you. So the best one is usually the one that gives us the most money for the amount that we're putting in. So let's start with the NatWest then. So the NatWest, we can see we've got 6.4%. It's compound interest. We're paid annually, so that means we're paid at the end of each year, and we're going to save for 3 years. So we've got our £1,000, our initial amount. Our multiplier this time then, 100 plus 6.4 is 106.4. We turn that into a decimal multiplier, we get 1.064. We're raising it to the power of 3 because we're being given interest annually, and there are 3 years. So once every 3 years means we're getting interest 3 occasions through that time. And that would give us £1,204.55. The Britannia account then, 1.7%, again compound interest, this time paid quarterly for 3 years. So our initial amount of 1,000, our decimal multiplier this time will be 1.017, and we need to work out that power. So quarterly means I'm getting 4 times per year. I'm being given interest over 3 years. 4 3s are 12, so our power is 12, and that gives us £1,224.20. Finally then, HSBC, 0.5%. Seems quite a low percentage, but that's because we're being given it monthly, so every month we're getting interest. So our initial amount of £1,000. Our interest rate then, so remember to add 100 first, then divide by 100, so we get 1.005, and our power this time. So we're getting interest 12 times every year for 3 years. 12 times 3 is 36, so 1,000 times 1.005 to the power of 36 gives us £1,196.68. So we need to decide which account we want to put the money in, ideally the one that gives us the most return, the most profit. So if we compare our values, then we can see that Britannia would give us the best return on our investment if we kept it in there for 3 years. Okay, so have a go with these then. Pay particular attention to whether you're being given interest per annum, so remember annum meaning yearly, or monthly or quarterly, to know how many times you're going to get interest throughout the period that you're saving for. So pause the video now, have a go at these. Okay, let's talk through the solutions for these then. Alright, so our first one then, we've got our 4%, 3 years, we're paid it per annum, so once every year, so our power is 3, and we get £4,731.18. For our second one, 3%, so 1.03, again per annum, so once every year for 5 years, gives us a power of 5, and we can see our total there. This one then, 0.6% per month for 2 years. So there are 12 months per year. 12 times 2 gives us our 24. And we've been careful here with our decimal multiplier to make sure we've got the right amount of zeros in there. The next one then, 5.5% per annum for 4 years. So 4 times throughout the period. Gives us our total of £11,669.73. And finally then 0.25% per quarter for 6 years. So 4 quarters per year. So 4 times 6 gave us a power of 24. And again, being careful with our decimal multiplier. So we add 100 and then divide by 100. Check your answers, make sure you're happy with those before you move on. Okay, finally for today then, Probably quite an apt question at the moment. But we've got an infectious disease that's causing an epidemic. Again, these are often modelled mathematically. So this particular epidemic is mathsitis, and it makes people fall in love with maths. So hopefully that is spreading around the UK as well at the moment. So we've been given our formula then to work out the number of people infected. So we're told that N is the number of people, S is the starting number of people. We're going to multiply that by M, which is our percentage multiplier, and T, our power, is the number of days the disease spreads for. So based on the model, we want to work out how many people would be infected after 1 week if the percentage increase was 20% and the starting number was 1 person. Then how many would be infected after 2 weeks and how many would be infected after 5 weeks. So pause the video now then, have a go and see if you can work out how quickly mathsitis will spread. Okay, so using our formula then, so S being the number of people infected, so we had 1 person infected. The increase was 20%, so that's 100 plus 20, as it's an increase of 120%, which is 1.2 as a decimal multiplier. We wanted to know for 1 week, we were told T was the number of days, so there are 7 days in 1 week, so our power is 7. And to the nearest whole person, we would have 3 people. We've rounded down the number of people, we can't have a bit of a person, so we've rounded it down. After 2 weeks then, still starting with our initial 1 person, and this time we've changed the number of days then to 14. So 2 weeks, 14 days, we would have 12 people. And again, if it only started off with that 1 person, after 5 weeks, 5 times 7 is 35 days, 590 people would be infected. So you can see it will spread quite quickly. Okay, well, I hope you enjoyed that lesson then. The next lesson we'll be looking at compound depreciation. So click on the link to move on to the next lesson when you're ready, and don't forget to subscribe.